Hey, my name is Marina Kao and this is Lab Report 1, which focuses on constant velocity of a moving object. The purpose of this lab is to have a deeper understanding of the Newton's second law, which states that the time rate of change of the momentum of a body is equal in both magnitude and direction to the force imposed on it. In other words, when an object has a constant velocity, the net force on the moving object has to equal to zero according to the formula given down below. To achieve the purpose of this lab, I used a small spherical ball as the object in motion and analyzed its horizontal motion at a constant velocity. It moves on a relatively smooth countertop surface to make sure the air resistance and friction are small enough to be negligible. After recording the object's linear motion, I used the app tracker to track its motion, and the results are down below as shown in the video. Then I used a computational model called GlowScript and predicted its motion by the computational model. And then I used Excel to compare these two different models. In this lab, the ball is the system and the world is the surrounding. The relationship between the position and time is linear, which means the object actually moves in a constant velocity. According to the data table by tracker, the initial condition is down below. So the initial time is at 0.033 seconds and the initial position is negative 0.22700, and I used the equation delta V equals delta x over delta t to calculate for the velocity, and the result is down below in the chart. These are the screenshots from my GlowScript code. I mainly just copied and pasted the starter code, but I changed the start of the vector for initial position and initial velocity in terms of my own experiment condition. As I mentioned in the previous slide, how I calculated the initial velocity is by using the formula delta V equals delta x over delta t, and I applied the real numbers using the tracker data table. I compared these two different models through Excel, and according to the graph, there is a huge portion of overlap in terms of these two linear lines, which means my result is pretty accurate. I listed 3 possible reasons of error. The first one being that the net force may not be zero due to friction and air resistance, and the second one being that the motion may not be perfectly horizontal, which means the coordinate on the z-axis is not zero. And the third one being that I tracked the motion by hand, which means the data on the tracker app may be a little off. If the positive x-axis and negative x-axis were interchanged on tracker, the graph on the top right corner that reflects the relationship between x position and time in seconds would be decreasing instead of increasing. However, the absolute value of the slope would still be the same. It would just be negative. And same thing happens with the y-axis. So it would just be upside down. I think it's not possible to determine every push and pull that acts upon the object in motion, as there are just way too many unknown variables in this case. However, based on the information that we do know at the moment, we're able to at least determine the mean forces, which are gravitational force, normal force, the initial push from my hand, and the frictional force. In conclusion, this lab is a real-life implication of Newton's second law, and by performing this experiment, I understand the nature of constant velocity a little better, and I also comprehended the possible sources of deviations from the perfect model.